All right, we're going to finish chapter 1, section 6 with rational and absolute value equations. All right, so there's really nothing new with this lesson, at least this first part of this lesson, right? Because rational equations we actually solved in 1.2b. All right. Some of these examples might be a little bit more complex, all right, but it's essentially the same idea, right? You're going to multiply by the least common denominator, cancel it out, and then you solve whatever's left over, all right? And then you want to check for any extraneous solutions, right? Keep in mind you never want 0 on the bottom, right? So you never want 0 there, right? That's going to make a solution extraneous. So if I have like 1 over x, right, that cannot be equal to 0. If I have 1 over x minus 1, then x cannot equal 1, right? Because 1 minus 1 is 0, all right? All right, so let's try some of these examples, right? Some of them look nothing super new, right? They're things that we've done before. All right, so looking at this first one, I want to multiply this entire equation by a least common denominator. Now, doing that is going to get rid of our denominator, so I'm going to explain it maybe a little bit differently than I did in my 1.2b lesson, right? I'm just going to multiply each fraction by whatever's missing, right? So our least common denominator here is going to be a 4 and an x plus 1, right? They don't really have anything in common. And then this x on the other side of the equal sign, right? Let's pretend it has a 1 on the bottom. All right, so our least common denominator is going to be 4 and an x plus 1. So then I'm going to go one by one, right? Let's look at this fraction right here, right? It has the 4, but it doesn't have the x plus 1. So that means I'm going to want to multiply 4x plus 3 by x plus 1. All right, I can do the exact same thing over here, right? This has the x plus 1, but it doesn't have the 4. So I'm going to bring everything down. It's going to be a minus 2x times the 4, all right, equals x over 1, right? It doesn't have either of them. It doesn't have the 4 or the x plus 1. So I'm going to multiply x by 4 and the x plus 1. All right, and then we just want to solve this equation, right? So let's clean it up a bit, right? It looks like over here I can FOIL. And then you're left with a 4x squared plus 4x plus 3x plus 3. And then minus 2x times 4 is going to get us a minus 8x. And then x times 4 is going to get us a 4x. And then if I distribute 4x, then that's going to leave us with equals 4x squared plus 4x. All right, and then we want to solve this equation. We can combine like terms or get everything to one side, set it equal to 0. But when I do that, right, I'm going to subtract 4x squared on both sides, right? I see a squared, that's going to give us some clue that there's probably going to be a quadratic that we have to solve. But if we do that, notice 4x squared and 4x squared completely cancel out. And then 4x and 4x also completely cancel out. So I'm left with a 3x plus 3 minus 8x equals 0. All right? So this really leaves us with a linear equation, right? This is something a little bit simpler that we can solve, right? 3x minus 8x is going to get us a negative 5x. Plus 3 equals 0. I can subtract 3 on both sides. And then I end up with a negative 5x equals negative 3. And then divide by negative 5 and I get x equals 3/5, right? And when I plug this into the denominator, we're not going to get a 0, so this is a valid solution. All right, we can try the exact same thing with the next one. All right, so we have a common denominator of x minus 4. All right, this 4 over here has a denominator, we can say of 1, so I'm going to write 4 over 1. All right, so again, off to the side, I would write my common denominator, which is x minus 4. I'm going to see what is everything missing to get an x minus 4, right? This first one's not missing anything, so I can carry down that x. All right, this other x minus 4 is also not missing anything, so I can carry down that 4. All right, and this 4 over 1, I'm missing the x minus 4. So it's going to be a plus 4 times x minus 4. And then we end up with a very simple linear equation, which we can solve now. All right, so this is going to be an x equals 4 plus 4x minus 16. All right, combine like terms, and then I just want to solve for x. simple linear equation. So I get x equals 4x minus 12. Subtract 4x on both sides. And then I get a negative 3x equals negative 12. Divide by negative 3. And we get an x equals 4. All right, but now we want to check, right? If I plug this into the bottom, will I get 0 in the denominator, right? And if I do 4 minus 4 and 4 minus 4, we do get 0, right? So this is not a valid solution, right? So this one would actually have no solution. Right, so pretty simple to check your answers, right? It shouldn't really be anything super tedious, right? It shouldn't be that rigorous of a check, right? It's just, you're just trying to see if you get 0 on the bottom. All right, this next one, similar story, right? I want to try to get a common denominator, multiply by that common denominator. Check if we can factor anything first, right? It looks like this x squared minus 4 is a difference of perfect squares, so that's going to become an x plus 2 and an x minus 2. All right, so it looks like our least common denominator is going to be x minus 2, right? I see that. And an x plus 2, right? I see that as well. I don't see anything else, so this is my least common denominator, so I'm going to go one by one, right? 3 over x minus 2 is missing x plus 2, so I'm going to carry down that 3 and then multiply it with x plus 2. I can do the exact same thing over here. And I can multiply 1 by x minus 2 since it's missing the x minus 2, but it has the x plus 2. So plus 1 times x minus 2 equals, and then 12 over x squared minus 4, right, has both of them. So all I need to do is bring down that 12. All right, and so I can distribute and then simplify. So I get a 3x plus 6 plus x minus 2 equals 12. Let's combine like terms, so I get a 4x plus 4 equals 12. I can subtract 4 on both sides, and so I get a 4x equals 8. Divide by 4, and I get x equals 2. All right, but once again, you want to check if that gives you 0 on the bottom, right? Over here, it doesn't give me 0, right? 2 plus 2, right? But here it does, right? I get a 2 minus 2, which is 0. All right, 0 on the bottom is undefined, so this is not a valid solution. This entire equation would have no solution. All right. So now looking at some harder examples, some of them might require a little bit more steps. Some of them might leave you with a quadratic where you have 2 solutions to check, right? This first one is an excellent example of that, right? This one looks pretty complicated with those denominators. But once again, let's just try to factor everything, right? So 3 over that on the bottom, we can factor, right? So x squared plus x minus 2 can become an x plus 2 and an x minus 1, right? Factors of negative 2 that add to 1, all right? X squared minus 1 on the bottom over here is going to become an x plus 1 and an x minus 1, all right? And then this over here, it looks like I can take out a GCF of 2, and I'm left with an x squared plus 3x plus 2. And so factors of 2 that add to 3 are going to be 2 and 1. So I get a 2x plus 1, x plus 2, right? So let me get rid of that. All right, so we have a lot of things on the bottom here, but I'm just going to write it off to the side, making sure not to repeat anything. I know for sure we have that 2, so it's going to be a 2. I have an x plus 2, and then I have another x plus 2, so I'm just going to write it once. All right, x minus 1 and an x minus 1. I'm just going to write it once. And then I have, lastly, an x plus 1 and an x plus 1. And it looks like we've accounted for everything, right? So there's nothing else that's missing. All right, so now let's go one by one, and let's see what's missing from each denominator, right? So looking at this first one, this first fraction right here, it has the x plus 2 and the x minus 1. It doesn't have the 2 or the x plus 1. So I'm going to do a 3 times 2 times x plus 1. All right, carry that minus. It's going to be a minus. This has the x plus 1 and the x minus 1, but it doesn't have the 2 or the x plus 2. So it's going to be a 1 times 2 times x plus 2. All right, and then equals, Over here, I have the 2, the x plus 1, and the x plus 2, but the only thing we're missing is the x minus 1. So this is going to equal 7 times x minus 1. All right, and then we can just simplify this as much as we can, right? So 3 times 2 is going to get you 6, and then I can distribute 6 to each of these in the parentheses, so that's going to leave me with the 6x plus 6. All right, minus 1 times 2 is going to get me a negative 2. And then I can distribute negative 2 over here, and that's going to get me a minus 2x minus 4. Equals, and then over here I can distribute 7. That's going to get me a 7x minus 7. All right. So it looked like a super complicated equation, all right? But really we're left with a linear equation, right, after eliminating our denominator. Right, so let's combine like terms and solve for x. Right, so 6x minus 2x is going to get you a 4x. And then 6 minus 4 is going to get me a 2. Equals 7x minus 7. All right. We can subtract 7x on both sides. And then subtract 2. And then so we're left with negative 3x equals negative 9. Divide by negative 3, and I get x equals 3. All right, and if you check, there's nowhere in the denominator where if I plug in 3, I'm going to get 0 on the bottom. So this is a valid solution, right? So x equals 3 is my solution. All right, let's try the same thing over here. All right, so again, I want to make sure that everything is fully factored before deciding on the least common denominator. It looks like here I can take out an x, and it's going to leave you with an x plus 1. All right, so then off to the side, I'm going to have an x plus 1. And then it looks like this fraction right here is missing the x. So I'm going to do an x times 4x plus 3. This fraction right here has the x, but it's missing the x plus 1. So I'm going to do a 2 times x plus 1. And then this fraction over here has everything we need, so this is just going to equal 1. All right, now let's distribute x. Distribute 2 to simplify as much as we can. So I get a 4x squared plus 3x plus 2x plus 2. Equals 1. All right, combine like terms. There is a squared in this problem, so we want to make sure that everything is on one side, set it equal to 0, and then we want to see if we can factor it. All right, so let's subtract 1 on both sides and then combine the 3x and the 2x. So this is going to get us a 4x squared plus 5x plus 1 equals 0. And so it looks like this is something that we can factor. So I'm going to do 4 times 1. Factors of 4 that add to 5 are 4 and 1. So it's going to be an x plus 4, x plus 1, divide by that 4, equals 0. All right, so this is going to leave me with an x plus 1 and a 4x plus 1 equals 0. And then set both of these equal to 0. I get x equals negative 1 and x equals negative 1/4. All right, now let's check, right? If I plug in negative 1, it looks like over here, negative 1 plus 1 is going to get me a 0, right? So this is not a valid solution. And it looks like when I plug in negative 1/4 everywhere, right, I don't get 0 on the bottom anywhere, so this is a valid solution, right? So my only answer here is negative 1/4. To write this on a test, right, as a valid answer, some people see that negative 1 doesn't work, but they'll write no solution. So this equation actually has a solution, but it's not negative 1. So just the way that I wrote it right here is perfectly fine, right? Just draw an x over whichever doesn't work, circle or box whatever does work, and I'm perfectly fine with that. All right, or you can say x equals negative 1 is not a solution, right? So not a solution, and then this one's a solution. Right, no matter how you need to specify it, but don't just write no solution because I might get confused and I'll see no solution when there is a solution. All right, so just be careful with that. All right, let's try the same thing with this one over here. So it looks like I have nothing over the 6, so I'm going to write a 6 over 1. I have a 2x minus 3, and then I have 2 of these 2x minus 3s. Right, so really my least common denominator is going to be both of them. It's 2x minus 3. And then keep in mind, squared is the same as if I wrote 2x minus 3 times 2x minus 3. So not only are there one of them that they share in common, but this one has 2 on the bottom. So I'm going to need to write 2 of them. All right, so that is actually my least common denominator. All right. So now I'm going to go one by one, right? It looks like this 6 over 1 needs both of them. So I'm going to do a 6 times 2x minus 3 squared equals, this one needs one of them. It has one already, but it needs 2 of them. So it's going to be a 7 times 2x minus 3. And then this one over here is just going to be a plus 3, right? It already has both of them on the bottom. I just needed to bring down that 3. All right, and then let's simplify this as much as we can. Right, so 2x minus 3 squared, right? This is just the square of a binomial. So if you know a special product, it should be fairly easy. So it's going to be a 6 times a 4x squared minus 12x plus 9 equals, I can distribute 7, and I get equals 14x minus 21 plus 3. And then I can distribute 6 everywhere. And then we end up with a 24x squared minus 72x plus 54 equals 14x minus 18, right? Just combine these two. And then this is a quadratic. We do have an x squared that didn't cancel out, so I'm going to move everything to one side and set it equal to 0. And so we're going to end up with a 24x squared minus 86x plus, should get you 72 equals 0. All right, so it seems like a lot, but let's see if maybe we can try to factor it to make it a little bit simpler, right? I don't want to jump and do 24 times 72. Let's see if we have a GCF. All right, so if there is one, that's always going to make your life a little bit easier. All right, so it looks like here I can take out a 2. So if I divide every single thing here by 2, then we end up with a 12x squared minus 43x plus 36 equals 0. All right, so still not fantastic, but definitely a little bit better than what we had before. So I can do 12 times 36. All right, we can do that off to the side if we need to. All right, why don't I do that with you guys, right? 36 times 12. All right, is going to get me 12, so with the 7, right? Bring down the 0 and bring down the 36. All right, so that's going to get me 432. All right, so I need factors of 432 that add to negative 43. All right, pretty big expression. I mean, pretty big thing to try to factor. I did this before off camera. I know it's going to be negative 36 and negative 27. All right, but again, like I said in the previous lesson, right, these are fairly complicated problems, right? So on a time crunch, I probably wouldn't give you something that you weren't able to do, right? It's not going to be humongous or ridiculously large, right? Because again, mainly we want to test on the concepts. I want to know if you're able to solve an equation that looks like this versus can you factor outrageously large polynomials, right? So it ends up looking something like this, right? We can do our slide and divide. I'm going to turn that 16 into a 4, this 12 into a 3, and I'm going to slide that 3 out front. So it's going to be a 3x minus 4. And then 27 and 12, I can simplify that into 9 over 4, right? Divide them both by 3. And so I can bring up that 4, and this is going to get me a 4x minus 9. And so setting both of these equal to 0, I get x equals 4/3 and x equals 9/4. All right. And so these are both valid answers, right? When you go to plug these back into the bottom, it doesn't look like we're going to get an extraneous solution, right? So you can even test it, right? If I try to plug in 4/3 and I do 2 times 4/3 minus 3, right? That's going to get us 8/3 minus 3, all right? And then I don't really know what number 8/3 is. I don't know that exact number. Well, the exact number is 8/3, but I do know for sure that 8/3 minus 3 is not 0, all right? So this is a valid solution. And same thing with 9/4. If I did 9 over 4, right, 2 times that minus 3 is going to get me 9 over 2 minus 3. And once again, that's not 0, right? So these are both valid solutions. All right, now moving on to absolute value equations. Some of these examples are pretty easy because maybe you remember them from Algebra 1. But one thing to remember about absolute value is it's always going to be a positive. So let's say I have the absolute value of 5. All right, that's just 5. Right? But if I have the absolute value of negative 5, that is also 5. Right? So the absolute value is just the distance from a number to 0. Right? So when we solve absolute value equations, right? So let's say the absolute value of x is 5. Right? So I'm trying to think, what can I plug in here to get 5 as an answer, right? And there's one thing that I can plug in. I can plug in 5, but I can also plug in negative 5, right? So when we go to solve these equations, you remove the absolute value bars and you set the equation equal to the original and the opposite of the original, right? So just change the sign. You do want to check your solutions, all right? So sometimes you can check them, right? When it's equal to a number, you don't have to check it. It's only when the variable is outside of your absolute value, right? Because the issue with the absolute value, maybe you do everything mathematically correct, but it's going to end up equaling a negative number, right? And that's something that we don't want. So if it's already equal to a number, you don't really have to worry about checking, all right? It's only when it's on the outside. And that'll be our last two examples, right? But the ones on the next page should be fairly straightforward. And then one thing to note is that there is a special case, and it is when the absolute value equals a negative. If you have something like the absolute value of x equals negative 5, well, there's nothing that I can plug into this absolute value that's going to get me a negative, right? Because absolute value always equals a positive. So this is an example of something where you would get no solution, all right? So just something to keep in mind. All right, so let's try that here. I have the absolute value of 2x plus 1 equals 5. All right, my absolute value bars are isolated. So then what I can do is I can set up two equations, and I'm going to say 2x plus 1 equals 5. And then I have 2x plus 1 equals negative 5. All right, and so I just want to solve both of these. So I can subtract 1. I get a 2x equals 4. Divide by 2, and I get x equals 2. All right, and then subtract 1 over here. I get 2x equals negative 6. Divide by 2, and I get x equals negative 3. All right, and these are both valid solutions because they equal a number, right? So no matter what I plug into this absolute value bar, I'm always going to get a positive number. And because we actually solved this equation, I know that these two answers that we just used are valid solutions that when we plug in, we're going to get 5 as our answer. All right, looking at this next one, I have my absolute value bars already isolated. I have everything else on the other side, which is, the setup is perfect, right? We can go ahead and try to solve it. But notice that this equals a negative number, right? And we just discussed, can the absolute value of anything equal a negative number, right? It never happens, right? There's nothing that I can plug in for x that's going to get me negative 5 or even any sort of negative number. So this is automatically a no solution, right? I don't even need to split up my two equations and try to solve, because I know for sure that the absolute value of a negative is always, the absolute value of anything is always going to get me a positive, never a negative. All right, so hopefully that distinction's clear. This first page went by pretty quickly because, a lot of this was maybe from Algebra 1. We remember solving these kinds of equations, but regardless, right, these should move fairly quickly. All right, now it's ones on this page that might take a little bit more time, right? They're not as straightforward because we're going to end up with quadratics. And then you're going to see these get really tedious because we get 4 different solutions, only a couple of them work. But again, tedious doesn't mean it's difficult, right? You're going to see the math here is actually pretty easy, all right? It's just actually checking the solutions that might take a little bit more time. But regardless, let's get started. It looks like with this one, I have my absolute value bars already isolated, and it's already equal to something, right? So I can immediately split it up and then set up my two equations. So I'm going to have x squared minus 3x equals the original, so negative 4x plus 6. And then I'm going to set x squared minus 3x equal to the opposite of the original, so negative 4x plus 6. All right, keep in mind the entire thing has to change sign, so I'm going to put negative around parentheses. right? And I'm going to solve the left-hand side first. All right, so this leaves us with a quadratic, which we can set equal to 0. So I'm going to add 4x, subtract 6, and then you're left with an x squared plus x minus 6 equals 0. All right, so the actual factoring and solving part is actually super easy. All right, so I need factors of -6 that add to 1, and it's going to be an x plus 3 and an x minus 2. And then so we end up with x equals -3 and x equals 2. All right, so we get these answers. Now let's go on to checking. All right, so I don't want to try to waste too much time with the checking. You want to be kind of wise with your checks, right? So I'm going to check up here. Keep in mind the only issue that we would get with absolute value equations are if you get a negative outside of your absolute value, right? Because you never want to set it equal to a negative. So no matter what's in here, it's going to be positive. Let's see if we plug our answers in, do we get negative numbers on the other side, right? Because there is an x right here that could give us an issue. So I'm going to check x equals -3, and that's going to get us a -4 times -3 plus 6, and that's a 12 plus 6, which is 18. All right, so that means whatever I plug in here, even if it's a -18, it's still going to work because the absolute value of -18 is 18. All right, so I actually don't really need to do much more than that, right? So this already is a valid solution. All right, now let's check x equals 2. Let's see if that works. And again, I'm going to check it on the side that could give us an issue, right? Over here, I have a -4 times 2 plus 6, which is a -8 plus 6, and that's a -2, right? And we can stop right there, right? Because no matter what I put in this absolute value bar, I know for sure that it's never going to equal a negative. So it for sure is not going to equal -2. I can immediately cross this one out after that realization, right? So that hopefully should save you a little bit more time with the checks, right? If it's outside of the absolute value bars and you get a negative, that solution does not work, all right? So let's try the exact same thing with the other side. Right, so we already checked 2 of our solutions and we got 1 of them. Let's try the same thing over here. Right, so I want to distribute that negative and then just do the exact same process. So I'm going to get an x squared minus 3x equals 4x minus 6. I can subtract 4x and add 6 on both sides. And this is going to leave us with an x squared minus 7x plus 6 equals 0. Factoring this is going to get us an x minus 6 and an x minus 1. And so I end up with an x equals 6 and an x equals 1, right? Once again, I do want to check these, right? Because maybe one of them doesn't work. But once again, I'm going to plug it into the side that could give us an issue, right? And we'd only get an issue with absolute values if it equals a negative. So I'm going to check this side now. Let's check x equals 6. Let's see if that works. I get a -4 times 6 plus 1. That leaves us with a -24 plus 1. Which is -23, right? And again, I can stop right there because I know for sure, oh, sorry, not 1. I don't know where I got 1 from, right? 6. -24 plus 6 is -18, right? Either way, right, we get a negative number, right? And I know for sure that the absolute value of anything cannot equal a negative number, so this 6 will not work. All right, let's try the same thing with x equals 1. So I get a -4 times 1 plus 6, which is -4 plus 6, and that's going to leave us with a 2, right? And that is a positive number. So that means if I plug in 1 over here, even if it does get us a -2, right? So I can verify that, right? 1 minus 3 times 1 is 1 minus 3, so -2. Even though I got a -2, it was inside of these absolute value bars, which does leave us with a +2, right? So x equals 1 is a valid solution. So we get 2 solutions here out of the 4 that we got that are valid, right? So it's x equals -3 and x equals 1. All right, so pretty tedious, right? The math itself maybe isn't super difficult. It's just the checking part of it that might be a little bit time consuming. All right, so let's try the same thing over here. All right, so again, I'm going to split this up into 2, and I'm going to set up my 2 equations. I'm going to get an x squared plus 4x equals the original, so 7x plus 18. And then I'm going to get x squared plus 4x equals the opposite of my original, so -7x plus 18. All right, and then I can distribute that negative, right? I'll just start over here. So x squared plus 4x equals negative 7x minus 18. I can add 7x and add 18 on both sides. And then everything on the right-hand side is going to become 0, and then I get an x squared plus 11x plus 18 equals 0. Right, and then factoring this, factors of 18 that add to 11 are 9 and 2. So then I get x equals negative 9 and x equals negative 2. All right, and then we do want to check these. Check. Hang on. All right, so let's check negative 9. All right, and again, I'm going to plug it into the part that could give us an issue, right? Because keep in mind, we don't want negatives on this side of our equal sign. If I get a negative in our absolute value, that's fine, right? Because it's going to become a positive, all right? But on the outside could give us an issue. So I'm going to plug in a negative 9 over there. So this is going to give me a 7 times negative 9 plus 18, which is negative 63 plus 18, which gets us a negative 45, right? And that is a negative number, so negative 9 does not work. And let's check x equals negative 2. All right, so it's going to get us a 7 times negative 2 plus 18, which is a negative 14, plus 18, which is 4. 4 is a positive number. It does work. So that means negative 2 is a valid answer. All right. Now let's try the same thing over here. Let's solve this side of it. So I'm going to subtract 7x on both sides, subtract 18 on both sides, and so I end up with x squared minus 3x minus 18 equals 0. And then I want to factor. Factors of negative 18 that add to negative 3 are a negative 6 and a positive 3. All right, so then I get x equals 6 and x equals negative 3. Again, I do want to check these. All right, so making sure that these are valid solutions, let me check right here. I'm going to plug in 6. I get a 7 times 6 plus 18 is going to get us a 42 plus 18, which is 60. That is a positive number, so this one is going to work. And let's check negative 3. So I get a 7 times negative 3 plus 18, which is negative 21 plus 18. That gets us a negative 3, right? And because it's negative on this side of the equal sign, negative 3 is not a valid solution. So I only have 2 here again, right? I have 6 and negative 2. All right. So this section, this page, is the only thing that's probably new from Algebra 1. And it might be a little tedious, right? But once we're comfortable with the process and factoring and getting our solutions and knowing what makes a solution valid versus an invalid solution, then it shouldn't be anything super difficult. It might be a little bit time consuming, but hopefully this makes sense.